Okay, so quick refresher on yesterday. We talked about how to convert from degrees to radians and radians to degrees. So from degrees to radians, we take theta, we multiply it times pi over 180. Radians to degrees, we take theta and we multiply it times 180 over pi. We learned how to find coterminal angles in both degrees and radians. Degrees, we add and subtract 360, and degrees and radians, we add and subtract 2 pi. And then we started to build our circle. We talked about our quadrant angles. So 0 and 360 are at the right in degrees. 0 and 2 pi are at the right in radians. Actually, it would be 0. Let's do it the way that the unit circle does. 0 and 0 for both radians, and then 360 and 2 pi. So this is both degrees and radians at the start, and then you go all the way back around and it ends at 360 for the degrees and 2 pi for the radians. At the top is 90 degrees or pi over 2. On the left is 180 degrees or pi. On the bottom, 270 and 3 pi over 2. And if it's positive, you're going counterclockwise, so it'd be this way. If it's negative, you're going clockwise, which is this way. Again, we're going to fill in the rest of that circle today after we finish notes. So we left off on complementary and supplementary angles. Complementary angles are two angles that sum to 90 degrees. So if they're in degrees and I want to find its complement, I do 90 minus the angle. Because 90 and pi over 2 are the same, this would be degrees. 90 and pi over 2 are the same. If it's in radians, then I do pi over 2 minus the angle. And supplementary are angles whose sum to 180 degrees. So if I'm finding the supplement and it's in degrees, I do 180 degrees minus the angle. And if it's in radians, I do the radian version of 180, which is pi, minus the angle. Both complements and supplements have to be positive. So if something is greater than 90, there is no complement. If it's greater than 180, there is no supplement. Now you can, if you're more comfortable dealing with degrees, you can take a radian, convert it to degrees, then find its complement or supplement, but then you have to give it back in radians. So whatever form the original question is asked is how you must give the answer. If it was asked in radians, you got to give it radians. If it was asked in degrees, you got to give it degrees. All right, so example 4 says, find, if possible, the A complement and B supplement to each angle. So again, complement, we would do, this one's in radians. I would do pi over 2 minus 3 pi over 4. But what's going to happen? What's true about 3/4 and 1/2? 3/4 is bigger than a half, right? If you catch it from the beginning, you don't even have to do the work. But if you don't, I'm going to change this. So it'd be 2 pi over 4 minus 3 pi over 4, which is negative pi over 4. And a complement cannot be negative. So for A, we would say no complement. And then B is pi minus 3 pi over 4. Pi becomes 4 pi over 4 minus 3 pi over 4, or pi over 4. That's the supplement. For B, now we're in degrees, so if I want to find the complement, I do 90 minus 82, or 8 degrees. And if I want to find the supplement, I do 180 minus 92, or 98 degrees. Good so far? This is still right, but this should have been at 82. All right, last thing in 4.1 is arc length. Remember from geometry, Arc length is the perimeter of my circle. It's a portion of that perimeter or a portion of your circumference. So if you picture like a pizza, this would be the pie, the crust of the pie. Arc length is a unit of measurement that would be in something like inches or centimeters because it is a length. Like if I actually took a string and I measured it on the outside and then put it against a ruler or something like that, that would give you your arc length. When you're dealing with a circle and you have the angle, we use this formula, which I actually just changed the order so I can remember it, and I call it SOAR. It is S, which stands for arc length. I don't know why, but it does. And then theta times R. But the important thing is your theta must be in radians. So if it's given to you in degrees, the first thing you're going to do is convert it to radians and then multiply it out. Obviously, if it's already in radians, you can use it. So this is going to give you this, the length of that curve. The first example says find the length of the arc, and for number 1, you're given R is 3 and theta is 120. So we just said S equals theta times radius. But what's true about theta? Has to be in radians. So if you look at 120 is not in radians. How do I convert from degrees to radians?
Radians over, or pi over 180.
Good. And then I can cancel through my zeros. 6 goes into both of those, 2 and 3. So theta is 2 pi over 3. And my arc length equals that times the radius. And I can simplify this. The 3's cancel. And my arc length is 2 pi. If the radius had a unit on it, I would add it. If it said like inches or centimeters or whatever, I would say it's 2 pi inches or 2 pi centimeters. And if it says, I actually think some of them on the web assign want you to round, you'll actually multiply this out, like do times the pi button, and then round it to whatever it says. All right, 2 gives you theta is 4 pi over 5, and it doesn't have a degree symbol, which means that's already in radians, and then your radius is 7, so I literally just have to multiply those 2 out. And I get 28 pi over 5. You'll keep that in terms of pi unless it tells you to round it. If it told you to round it, you'd multiply that out. So I'd do 28 times pi divided by 5 or 28 divided by 5 times pi. It doesn't matter the order you do that in. And then you'd round. So if I use the calculator, I'd end up with 17.593 if you round to the thousands. Again, centimeters. Questions on that one? All right, example 6. Now it says find the radius of the circle with the given information. So they're just giving you different information, but you're using the same formula. This time it says the length of the arc is pi. That means S is pi, and theta is 3 pi over 4. Is that in degrees or radians? Radians. So then I would say pi equals theta, which is 3 pi over 4, times R. And I want to isolate that R, so you could do this in steps. You could do this in shorter steps, but you could do multiply by 4. Now that's gone. I get 3 pi R equals 4 pi. I could divide both sides by 3. I could divide both sides by pi. I could divide both sides by 3 pi. It doesn't matter what order I do that in. And the pi's cancel, and I get R is 4/3. I think it says keep it exact in the on the web assign. If it didn't, you would round that. That would be like 1.3 repeated. And then B, S is 24 pi. Theta is 4 pi. So if S is 24 pi and theta is 4 pi, I again can divide them both at the same time. And the pi's cancel, and I get R is 6. Questions? All right, go to your unit circle. So you will obviously, you need to know this. You actually need to know this for standardized tests beyond just this class, but also you're going to get, so next week's quiz part of the points is going directly to unit circle. You're going to fill in your unit circle. And then in 4.2, we apply that unit circle to a bunch of questions. So we're going to start. Let's start with the things that we already know and have literally reviewed yesterday, which is the quadrant angles. So everywhere you see a line with a degree symbol, that's where you're putting your degrees. So we start at 0. At the top would be what? At the very top, not the next line. The very top. 90. On the left, 180. On the bottom, 270. Underneath the 0 goes where it ends, which is 360. Do you remember the pattern from last year? 30, 15, 15, 30. So as you go around your circle, you're literally adding 30, then 15, then 15, then 30, then 30, then 15, then 15, then 30. The benefit of starting the way that we just did is it's almost like a check. When I get to 90, would that have been what I put there? So you can know if you're doing it in the right order. So 0 plus 30 is 30. Actually, let me do it in the same color. 30, 15, 15, 30. So this is 30, add 15, I get 45, add 15, I get 60, add 30, and I'm at 90, which is where it should be. Repeat that pattern again. Add 30 to 90, 120. Add 15, 135. Add 15, 150. Add 30, and I'm at 180. Do it again. Add 30, 210. Add 15, 225. Add 15, 240. Add 30, I'm at 270. Last time, add 30, you're at 300, 15, 315, and 15, 330. Add 30 and one more time, and you get to 360 that's there. So those are the angles, degrees. You're basically 1/4 the way there already. 1/3 the way there. And then we're going to do radians. So let's start with the quadrant angles again. What goes on the right? 0. What's the radian at the top? Pi over 2. What's on the left? Pi. What's on the bottom? 3 pi over 2. And what's on the right under the 0? 2 pi. Now the pattern for the rest of the lines is the line nearest the x-axis. So the one closest to our x-axis is over 6. So this goes over 6. We're going to fill in the top in a minute. But over 6, over 6, over 6. The one closest to the y-axis is over 3. Over 3, over 3, over 3, over 3. And the one in the middle is over 4. Over 4, over 4, over 4, over 4. With me so far? Yes? All right, first quadrant gets pi as its numerator because pi over 6 is 30 degrees, pi over 4 is 45 degrees, and pi over 3 is 60 degrees. If you question it, convert it and make sure it works. Then in the second quadrant, your numerator is 1 less than your denominator. So this would be 2 with a pi over 3, 3 pi over 4, and 5 pi over 6. The third quadrant is 1 more than your denominator. So 7 pi over 6, 5 pi over 4, 4 pi over 3. And the fourth quadrant, there's 2 ways to do it. One is it is 1 less than double, because double would be 2 pi. So 1 less than double. The other is literally memorize 5, 7, 11. 5, 7, 11. How many of you could have done this at the start of the day? Out of curiosity. You could remember it? Okay. Questions on that one? So if at any point you weren't sure, but you knew the degrees, you could literally multiply it times pi over 180 and you could check yourself. You do not want to do that all the way around. You would never be able to finish this. Yeah. No, if you had the degrees and you were converting to the radians, you would multiply. Like if I had 30, I would multiply 30 times pi over 180 to know what that is pi over 6. You're saying go back the other way? Yeah, if you were checking to make sure you were right, then you would do 180 over pi. Sure. All right, now in each quadrant, this is a unit circle, which means your radius is 1. So the furthest point out in your north, south, east, west directions, or up, down, right, left, is 1. You're literally going to the right here, 1. So your coordinate point is 1, 0. Because your x is 1. You didn't go up or down at all, so your y is 0. At the top, you're going up 1. So your x doesn't change. It would be 0. But the y is 1. The left, you're moving left 1, so it's negative 1, 0. And at the bottom, you're moving down 1, so it's 0, negative 1. Those are your 4 quadrant coordinate points. And then for the coordinate points that are next to your radians, we follow this pattern. All the over 6's are root 3 over 2 and 1/2. We're going to worry about the positive negative sign in a minute, but every over 6 on this circle is going to have that coordinate point. Every over 4 has the coordinate point root 2 over 2 and root 2 over 2. And every over 3 has the coordinate point 1/2 and root 3 over 2, the reverse of the over 6. Just memorizing that alone will help you in the next couple sections. Like just knowing if it's an over 3, it's this point, or if it's an over 4, it's this point. If it's an over 6, it's this point. Then we worry about the signs. So I'm going to go in and fill in all the over 6's, root 3 over 2 and 1/2, root 3 over 2 and 1/2, root 3 over 2 and 1/2, root 3 over 2 and 1/2. All the over 4's, root 2 over 2 in both spots. And all the over 3's, 1/2 and root 3 over 2. All right, so now think about your positive, negative signs in the quadrants. In your first quadrant, what's true about your x and y? They are both positive. So these are all going to stay just as they are. Both x and y will be positive. In the second quadrant, what's going to happen? The x is negative, so I literally put it on the front of the x coordinate. You have to change the actual coordinate itself. But the y stays positive. In the third quadrant, they are both negative, so don't just put a negative on the front of the parentheses. Both of them get a negative. And in the fourth quadrant, the y is negative. The x is positive because you're moving forward, but the y is negative, so you're moving down. Questions so far?